Welcome to our presentation. We, the team of GravityFree, are happy to showcase our work at Novel Observations in Mixed Reality, or NOMR. Instead of revisiting the same textbook-based concepts, NOMR enables students to explore and experiment with laws that go beyond in a virtual physics laboratory. After conducting field studies, user interviews, and usability testing with students, we identified the following key design questions. How might we design a new lab experience to simulate scientific thinking? Secondly, how might we design a collaborative lab experience that promotes group learning? First, let's address what we mean by scientific thinking. Scientific thinking is a form of intentional information seeking that employs observation, experimentation, and critical analysis. This became the main principle behind our designs for a new particle decay experiment for sophomores. In this, all students are divided in groups of 4, with one operating the VR and others supporting them as they spawn particles to observe. The lab instructions prompt students to explore daughter particles and use experimentation tools to measure the decay behavior more accurately. Students can experiment with various forms of simulation. For example, adding a magnetic field in the lab space to see the particles react to the new force and measure their tracks. Finally, our little particle also hides a third smaller, mysterious daughter particle that is hard to notice and only gets identified through clever use of the law of conservation equation. This secret planted encourages students to critically analyze their environment and deduce using scientific laws. Returning to our second design question, even after designing the particle decay interactions, we identified a gap in facilitating and engaging group learning experience. This led to us adding some significant changes in NOMR's flow, impacting onboarding, instruction delivery, and communication between VR operators and others. We introduced a new flow where NOMR identifies the creation of new boundary as a new student takes up the VR headset and triggers an onboarding flow that can be opted into. We also added a transparency mode for when the operator needs to communicate in the middle of the experiment. Additionally, we included the lab handouts in NOMR to enhance their understanding of the exercise. Lastly, by enabling other students to pin comments on the screen, we enhance more engagement and help them keep track of their findings. In conclusion, with our new particle decay concept and addition of new interactions, we hope to achieve a seamless and productive learning experience for all physics students.